So let me start that first. So the call is now indeed being recorded, as you can probably see on your respective devices. Right, so welcome everyone. The two main agenda items today that we're going to cover are firstly, Neil Cook from Open-Xchange is going to give an overview of the interim solution that we've identified for ISP DOE resolvers to allow their customers to access those resolvers even though they've got CPE with private IP addresses and they're running closed resolvers. This is intended to allow discovery through the auto discovery processes that companies like Google for Chrome and Microsoft for Windows 10 are either using or proposing. So Neil's going to give an overview of that in a moment. And then Iain is going to just give an overview of a paper that ATIS have recently published, giving a view of some of the technical impacts of DNS and privacy and security on network service scenarios, to read the title. So basically what are some of the potential impacts of encrypted DNS and some of the potential solutions to that for people. So that's the plan. So let me just let Stuart in from the virtual waiting room. So we'll cover those, and then time permitting we'll then pick up on any other business that anyone may wish to raise on the call. So without further ado, I can see Neil is indeed on the call, which is just as well. He's on first. So what I will do is I'll put on screen the paper with the interim solution outlined in a moment. But first, Neil, do you want to just say hello so I know your microphone's working properly?
Yes, sure. This is Neil Cook. Hi, I'm from Open-Xchange/PowerDNS. I can share it as well, Andrew, and then I can scroll through it. It might be easier.
Okay, try doing that. I can't remember if I've got share screen enabled. Yes, I have. Marvelous. Yeah, okay. In that case, Neil, fire away.
Thank you. So as Andrew said, we started working on this because the whole auto upgrade process from folks like Google and also Microsoft have announced a very similar process was coming to fruition, particularly in Chrome, which is now being released. And there were issues with that in that, so I've mostly changed, but PowerDNS is obviously the DNS part of that, and that's the part that I work for. And a lot of our customers have got CPEs by default, which do forwarding on a private IP address. So the CPE advertises a 192.168 address, for example, and then does DNS forwarding for the user back to the actual resolver sitting in the network. So the user's clients don't actually see the public IP address of the ISP's resolver. And the auto upgrade mechanisms for folks like Google, that doesn't work because they rely on the client seeing the public IP address of the resolver, not an RFC 1918 address. So we had to think about how we could solve this, and I made a proposal at a meeting that we had with some UK ISPs that Andrew organised a couple of months ago, and we came up with this paper, which I created, and that there's lots of folks have contributed to it, as you can see from the list here. So yeah, so a little bit of background. This is not trying to obviate the work that is being done in the ITF, the ITF ADD working group, which is designed to produce discovery mechanisms. I think some of the problems with discovery is simply that this is going to require changes to infrastructure in a variety of different ways. And one of the biggest issues is and you'll see from this document, and one of the things this document tries to do is document why it's so hard to change CPEs. And given that it's so hard to change CPEs, we wanted to come up with something that would actually work with the existing standards and infrastructure that is around today, as opposed to just updating all the CPEs to stop forwarding. And perhaps there are two reasons typically why we don't do that, or we can't do that immediately. And I'll go into those which are documented in this document. So I think possibly most folks know how the auto upgrade mechanism that Google and Windows are using works, but I'll just describe it. It's quite simple. The idea is that you will, as a DOH client, that they can upgrade without any kind of, or with, rather, I should say, a guarantee that they're continuing to use the same resolver that they were using before. And the way this works is essentially you, as an ISP, as a resolver operator, you get in touch with, say, for example, Google through the process that they actually have already announced. And then they essentially record your, and you have to kind of basically prove who you are and that you sort of own these services. And then what do Google do? They record the public resolver IP addresses that you have, and they record the URI templates that you have for your DOS service. And they just map those so that whenever they come across a resolver static configuration which matches ones that they find in this table, they can go, aha, we know that there's a DOS service for this, and they will automatically upgrade to the DOS service instead, which works great, but completely relies on the fact that it's a public IP address. So, but this does ensure that you're using the same vendor, essentially the same, not necessarily the same resolver, but the same vendor as you were using before you upgraded to DOH. So, as we already said, this has problems with CPEs doing forwarding. The script described the problem there. Most forwarders are using, CPEs are using DNS mask. And so we do describe in the document why not to just update all the CPEs to stop forwarding. And there's two reasons. I think the first thing is all about functional reasons. And this is more about really a documentation of why CPEs are doing this forwarding in the first place, because there is a sort of, I think, particularly if you're not an ISP, if you're not from that world, it's a very obvious question. Why are you doing this? Why are you doing this crazy thing? So lots of reasons. The main ones are around caching, for example. A lot of these are doing caching so that you, and actually as soon as you do a DNS query, it's already happened, then you'll get it from the CPE, which reduces load on the resolver infrastructure and also decreases latency for customers. Another one is local names. A lot of CPEs will have local names for things. A couple of other ones are around things like filtering. So CPEs can do filtering in the CPE, like network filtering, parental control, malware filtering, those kind of things. And obviously, if you're using the CPE to do that, you don't want to bypass the CPE. I've also seen use cases where CPEs are being used actually to send every request twice. So which doesn't necessarily decrease the load on the infrastructure, but it does ensure higher availability and better latency potentially, because it will go to two different sites, for example, of the resolver infrastructure, and then whichever one comes back first, it will be the answer. So, so that's another use case as well. Now, those are all reasons why CPEs do forwarding. Those aren't actually addressed by this document, because this document does propose essentially that clients ought to upgrade and do DOH directly to the resolver of the ISP, because again, to change the CPE to support DOH is a big infrastructure change, and that's not something that can be done immediately. And the primary emphasis of this document and the whole motivation behind it has been for ISPs who are launching DOH services to get DOH used in production with real users for things like Chrome in a short time frame, because there's all kinds of things coming down the pipe in the ITF that could make all this happen in a much longer time frame. But given the prevalence of CPEs, given how many CPEs there are out there and how long it gets to change them, it could be many, many years before those mechanisms are actually available to use in real world infrastructure. So very kindly, some of the contributors to this document have actually given us information about the CPUs in their network and the sort of issues that there are with upgrading those CPUs. So Deutsche Telekom, British Telecom, and Sky have all given information on this. And one of the things that would be great is we've had some preliminary chats with Google and Microsoft and other folks as well. And one of the things that would be great, and they've asked for, is getting more information from other ISPs, both in Europe, but also particularly outside of Europe. Anybody in the US, Asia, just to document their experience. Even if that experience is, hey, in this market, we typically don't do forwarding on CPUs or whatever it is, or our CPUs are super easy to upgrade. So what this does is talk about really penetration of CPUs, how many CPUs are provided by operators, how easy they are or not easy they are to upgrade, the different types, how many people they typically think are using the carrier DNS as opposed to sort of public DNS. And actually, interestingly, even those are 3 different ISPs, very, very similar statistics. So typically refresh cycle is very long. DT case here, it would take between 5 and 10 years to upgrade all their CPUs. In almost all cases, around 85 to 95% of people are actually using the resolvers of the ISP as opposed to public resolvers like Quad 8. So yeah, that's pretty interesting statistics, and just goes to show that even if 100% of Google Chrome users got the DOH auto upgrade facility, at least at these ISPs, and I think in Europe these are reasonably typical. We would love to see more information. That probably less than 10% of users would even have the possibility to use DOH or have DOH automatically upgraded. So I'm not going to go through all of the stats there. I think you've all got a link to the doc so you can read it. So here's our proposal. The proposal is really trying to go along the same lines as what the existing auto upgrade approach from Google and Microsoft is, which is to try as far as possible to use the same resolver infrastructure or the same company providing resolver infrastructure that you're already using. Now, this is essentially, sorry, someone say something?
I think somebody who should have been on mute, maybe that hadn't muted their mic.
Okay, great. Okay, so we talk about the proposal. We'll also talk about some security assumptions as well at the end. It's worth noting that this proposal is essentially a very simple technical proposal with a whole bunch of sort of policy and process wrapped around it, which is in many cases kind of what the existing Microsoft and Google proposals are anyway. And I'll go into that, but the core of the proposal, the technical core of the proposal is actually just pretty much lifted or inspired by one of the early discovery drafts, the pre-ADD working group, and the rest of it is basically inspired by what Google and Microsoft are already doing. So essentially, and I think it's worth noting, by the way, that in its current form, all this process and policy around it means that there's a lot of out-of-band non-technical stuff here, which most of that is not really suitable for standardization as such in the IETF. For example, when you have to sign up to this program, right? So the way that the Google program works today, it's just the same proposal that we're making for this. That's not exactly scalable. It's not something that really works long-term if you want thousands and thousands of people joining a specific program and managing that program. But anyway, it is what it is, and I think it certainly that's why we've termed this an interim discovery proposal as opposed to a sort of a final one, as it were. So exactly the same ways we already talked about already. ISPs would get in touch with, for example, Google, that they want to join this service, but they want to join it for this special type of auto upgrade process for CPUs. And as part of that, they have to guarantee that they will offer a DOS service on a URI which is closed. And that means only available to users on their own network, not from the public internet. Of course, it also has to be from a domain which the ISP owns. So sort of similar kind of restrictions in terms of making sure that you're not doing this for someone else who you're not actually responsible for. So so the closed part is very important, because what it does is it stops people from switching you from an on-net resolver operated by your ISP to an off-net resolver, even if that's not necessarily malicious, but it could be another trial participant. Now, so you have to provide this closed URI. You can also have a public DOS service that's not restricted, but it would have to be on a different URI. Now, similarly, as with the existing auto upgrade mechanism, then that list, those URIs go into a table which is maintained by the DOH client. Now, the actual logic for doing the upgrade is fairly simple. The process only starts if the configured resolver is a private IP address, i.e. an RFC at 1918 address. Then the client performs a text record lookup to a special use domain name. It could be any, I'm not wedded to the domain name, it doesn't really matter. And then the resolver is configured to respond to that special use domain name with a text record which contains the URI template of the DOS service. So it's entirely within DNS. And actually, the eagle-eyed of you will notice that Paul Hoffman has resurrected his resinfo draft, which originally, a while back, had the special use domain name lookup in it, which is what I was inspired to do this. They kind of moved away and went to IP addresses. Things actually come back now, and there's still IP address one for well-known URIs, but he's brought back the resinfo DNS lookup, which doesn't use a text record, it uses an URL, but that's kind of beside the point. So it's actually quite similar to an extant draft in the ADD working group as far as technical things are concerned, and indeed could potentially be aligned with that in the future, although it does depend on a new resource record, the Paul Hoffman resinfo draft. And then finally, so it does a text record, and then the client basically checks to see if the URI in the response matches one of these closed DOH URIs that have been added to the list via this out-of-band mechanism. And then normal HTTPS TLS validation takes place. So obviously, if it's anything other than the text record, then the discovery is terminated. This is all shown in a sequence diagram. And I've tried to document the variety of different scenarios, because there are quite a few different scenarios, particularly because some folks asked about the possibilities. Well, what if someone has a CPE that they've configured themselves? And I've tried to show what I think are the 4 main scenarios. I'd love it if someone could find different scenarios that aren't covered here. But essentially, the scenarios come down to, is your forwarder forwarding you to your local ISP resolver, or is it forwarding you to a non-ISP resolver, either a public resolver like Quad 8 or your own resolver, for example, which could even be your own local resolver, which you're running on a private IP address, which I show in DOH client 4 in this example. And I think there's another consideration, which is whether the user has intentionally installed a forwarder and doesn't want that forwarder bypassed, right? Now, in both of these scenarios, essentially there's only 2 differences between them, in that if you're connected to the DOS resolver of your ISP and your ISP publishes this special use domain name, then you will get upgraded to DOH and you will bypass the forwarder. You'll get connected directly to the DOH server. If you're not using one of those, if either your ISP doesn't support DOH and doesn't have this text record, or using a public resolver or a local resolver, whatever, that doesn't have the text record, then you won't get upgraded. So that's quite a simple distinction. Now, the point that I make in the document is that even though scenarios 1 and 2 may look similar, and I'll just go back to this diagram actually. So scenario 1 is that ISP has supplied the CPE and the DOH forwarder, but in scenario 2, the user has manually installed it, and they might have manually installed it for many reasons. For example, to do their own filtering, to do logging, to do their own caching, whatever it is. You probably don't want to do this automatically without asking the user, because in some of these use cases, like in scenario 2, even though it's technically the same as scenario 1, it is semantically different from scenario 1 in terms of user intention. So my sort of recommendation is that DOH client vendors would need to consider whether they ask users' consent to do this, and not necessarily do what they do today with the current mechanisms, which is auto upgrade. And then finally, we go through some security assumptions, and we try as far as possible to match what's available with the current. Auto upgrade is not entirely possible. For example, a downgrade attack is possible, which makes this opportunistic security. Of course, a downgrade attack would actually just present you with the status quo, because you wouldn't upgrade to DOH. But if you didn't use this, then you would still have the DOH. But it does mean that you can only consider this to be opportunistic. There is something which I've thought about for a while, which is having some kind of capability to have trust on first use, some kind of tofu style model where you could you could sort of remember that you're in the same network or whatever and use it. But it's actually quite difficult with that, because having had some conversations with various folks, it's actually very, very difficult to figure out if you're on exactly the same network as you were on previously, particularly things like Wi-Fi. On-path attackers can definitely change the discovery response returned from by the actual configured resolver. So they could send you to a different resolver, but that's where we come back to this closed mechanism. So the fact that it's closed means that they cannot send you to an off-net resolver, malicious or otherwise. It's just not possible, because that would not be open for you to access. That's the whole point of having all these resolvers closed. What they can do is that they can move you from a public resolver to the ISP resolver, and that risk is not mitigated. This is only obviously in the case of an on-path attacker, but it's still a risk that's not mitigated. And again, that's another reason potentially why you would want to ask the user if they want to change resolvers. Yeah, now, why an on-path attacker would want to do that, given that what the end result of that is that they have no access to the user, but you could consider it to be a DOS attack, for example. Yeah, so that's the kind of the basis of the proposal. There are some implications. We've kind of got a few things down here as to what would be required for DOH client vendors, particularly around checking of whether a resolver is closed and checking who owns particular resolvers, etc. But that's sort of, again, policy process stuff. So I'll leave it there, and I guess open up to questions if we have time.
Yep, we do have about 5 minutes if anyone has any questions. So thanks for that, Neil. Anyone want to come in with questions?
Yep, I've got one.
Okay, fire away, Jim.
Thanks so much, Andrew. Neil, this is an excellent piece of work. Well done.
Thank you.
Where do you think this document should go next? Is this something you might bring to the IETF at some point, or is it perhaps more suitable for publication through EDI? What do you think should be done next with this?
That's a good question. As I say, I think that the core of it is a very, very simple technical proposal, and as I say, it's very similar to the ResInfo draft from Paul Hoffman, except using a text record instead of a ResInfo record, and it's not using JSON and all that kind of stuff. So whether that could be aligned at some point is interesting, or even just proposing this, which is simpler, I guess. Not that much simpler, but a little bit. But that's, I don't know, that's not necessarily my preferred approach. Andrew and I have spoken about this. I'm not sure. Your second thing was actually publishing it, through the auspices of this organization?
Yeah, I was thinking maybe EDI might be a suitable venue if some of the stuff is likely to run into trouble with one of the existing IETF working groups. I mean, it would be great if Glenn was on the call at the moment.
Glenn is on the call, at least.
He is? Oh, great. Sorry, I didn't see him there.
Yes, he is. Yeah, just checked. He's on mute.
So I'll put him on the spot and see what Glenn thinks about this. Shut up now.
Glenn, do you want to come in there, or do you want to reserve judgment? Either's fine.
I'll reserve judgment. I mean, sorry, I'm also doing double duty. The transport working group over the ITF is debating SCE versus L4S at the moment, and so I'm dual tagging in dual video sessions.
Fine. Okay. Well, maybe hold that thought then, Jim. I guess part of the reason for this conversation was almost to sort of potentially pose that question amongst other things. So I think certainly the intent is after this call I'll put a link to the document onto the EDI list as well. I deliberately held off doing that until we had this call. And then, as Neil said, we've had a couple of conversations about whether this should also be evolved into an IETF proposal, either as is or potentially consolidated with one of the other recent papers. And it'd be useful to get views from people on this call, including yourself, Jim, if you've got any thoughts on that. And before you answer, I also saw Ralph had his hand raised, so I'll come to Ralph in just a moment. But did you have any thoughts yourself, Jim, based on what you've heard thus far?
I think it's a little bit too early to tell, in my opinion. I think it would certainly be helpful to document the problem space in an IETF setting, but coming up with potential solutions for that particular problem could be difficult at the moment, considering we've got 2 or 3 different conflicting ideas on what DOE or DNS discovery potentially could look like. Perhaps some of the document that Neil's got could feed into that work, but I think we have to be guided a little bit by what Glenn thinks might be the best way forward there. And again, is this going to be the right vehicle to get this material published?
Yeah, okay, fair point.
Yeah, and certainly I do think that some of the problem space stuff is actually potentially very interesting for an informational RFC, for example, or if nothing, it's a draft that could be useful just to give to the working group in terms of giving context, because I know there's a lot of people on the ADD working group that don't have a lot of this context in terms of understanding how ISPs, the issues with ISPs, and they just think everything's easy and etc.
Exactly, Neil, and that's why I think it would be so valuable to get this out somehow in an ITF setting.
Yeah. Full disclosure, by the way, I am working on I am a contributor to one of the drafts in the ADD working group around discovery.
So Andrew, can I just make a comment of what Neil just said? I agree with Neil's point that this does need to be brought, especially to the ADD group, especially as a use case for people to understand, because I think a lot of people there, frankly, don't understand this aspect of, not just aspect, but this need for operators. So, I do think that we need to get this circulated. After hearing the presentation and the material, I'm almost thinking that it's a 2-part sort of, you need the use case lead, which is, very typical for an IETF document, and then the proposed solution. And as we walk through that very interesting, path through that discussion, I think that trying to find a means by which the two of them can be separated out successfully, so that one doesn't just overwhelm the other in the conversation, would be necessary here, because I wouldn't want people to latch onto the proposed solution and say, well, I don't like the solution, therefore I reject the premise that you need it, which would be terrible. And that's not in any way my saying that I don't think the solution is a good solution. I just think that we got to make sure we have the conversation both of, here's the problem, let's agree on the problem. Now here's a proposed solution. Can we agree on that or not? And if so, why not?
Yeah.
Yeah, I totally agree with that, and I would definitely advocate splitting this into the 2 things, and whether you keep the second part in terms of the proposal. As I say, I'm already working on separate drafts on discovery, a long-term issue, but so I think splitting it in terms of here's the problems, here's the use cases is one thing, and I also think that what we're trying to address here is a short-term solution, and I do think that necessarily, and this isn't discussed in the ADD group that much, but there are, I think, different solutions to solving things in a short-term way versus a long-term way, because solutions that require lots of infrastructure changes are going to take a very long time to deploy, particularly with CPUs in the way.
Neil, one question. Do you also give any thought to some form of, I don't want to quite say user communication mechanisms, but mechanisms that the devices or things in the network could use to understand what's going on, that this is being offered and this is being done? Because I think that's an important part of the discovery process, whereas this is sort of like it just does it, if you see what I mean.
Yeah. So well, as I say, I do go through these different scenarios because I originally started off thinking, okay, there's going to be all these different scenarios, and we can try to work out what the scenario is. Problem is, it's really hard. But even though we know all of these scenarios, from the DOH client point of view, all of these scenarios look exactly the same because they don't know. Now, one of the benefits of using DNS to do this lookup, and obviously there are security implications of it as well, but one of the benefits is that you at least get the intention of the DOH, the DNS resolver that the user is already using. So if the DNS resolver doesn't support this mechanism, whatever it is, not wedded to any particular thing, but using DNS to do that is good because it means that whatever you've installed, you don't have to know on the DOH client. If the resolver doesn't support it, it doesn't happen. Now, as I already said, that there's this distinction between these two use cases where the user, you don't want to be bypassing the CPE if the user doesn't want you to bypass the CPE, which is why I think you need to ask users. But it's very difficult, in my opinion, to kind of understand as a DOH client what this all looks like. There could be 15 forwarders in the way here, and I just have no idea if they're there. And I think that's the issue I have with a lot of these drafts. Like any any discovery mechanism that uses an IP address to look something up is just fatally flawed in the face of chains of resolvers, even one. So, but yeah, I think understanding scenarios is important, and using that to inform what possible solutions might be. I think we're going to struggle to identify what these scenarios look like from a DOH client point of view. They all just look the same.
And on that note, I'm just conscious of the time. So can I just remind you, you've got the link in the meeting invite as well as on the chat. So if you haven't seen it in the invite, by all means cut and paste it from the chat. And if we put it onto the EDI list afterwards, that'd be an opportunity for people to continue the discussion and add any further thoughts, if that's okay.
And of course, anyone who wants to become an author or to contribute information to the document, particularly around CPU use cases in their organization, then obviously can contact myself or Andrew.
Yeah. Okay, thank you, Neil, for that. That's much appreciated. Right, so what I'd like to do now then is to move on to the second presentation, which Iain Sharp from ATIS is going to give. So Iain, if you want to come off mute just to make sure your mic is working okay.
Yeah, hiya.
Fantastic, that's a relief because I'm less familiar with your presentation, so this would have been a challenge for me to do. Right, I'll put the presentation on the screen.
Okay, so a bit of background. So I'm the technical advisor to the group in ATIS, which is working on DNS privacy and security impacts. So we go to the first proper slide, please. So for those of you who don't know ATIS, but I suspect many of you do, ATIS is primarily a North American focused standards and policy organization with a large membership of service providers, enterprises, and equipment vendors. And you can see on the slide there some of the strategic work that we're doing at the minute. We are also the North American partner for 3GPP. So the topic of DNS came to us really through Comcast. So we go to the next slide, please. So this Comcast brought the issue to us in July last year And we founded this group, DNS Privacy, Security and Services, under the chairmanship of Jason Livingood from Comcast, to really look at the whole issue of these emerging DNS protocols as they impact the membership, but particularly, I think, carriers and enterprises with a security requirement. And at the beginning of last week, we published the report, Technical Impacts of DNS Privacy and Security on Network Service Scenarios. And that consists of four main elements. Firstly, we're looking at this from the point of view of DNS as a platform for network services in carriers and enterprises. So we're trying to consider the full range of the ways that DNS is used inside those networks. And then with that in mind, we look at three aspects. So we define some use cases and reference architectures around those use cases. In fact, trying to flush out some of the complexities that Neil alluded to in terms of the many different ways that things can be configured. And then understanding the impacts of particularly dot and do in those scenarios, and using that analysis to generate some recommendations. Now, a lot of this, I think, is within this group of people is preaching to the choir, but I think what we're thinking primarily the target of this is maybe people who are not so well informed or not so up to speed on the issues of DNS evolution and DNS security as obviously the membership of any particularly this call is. But let me go on and talk a bit more in detail about what we looked at. So next slide, please. So this is just an example of one of the scenarios. So the scenarios we looked at were home networks, enterprise networks, mobile networks, and public Wi-Fi. This just gives you one of the scenarios and the kind of architecture diagrams that we created. So this is the home network case. And what we've kind of tried to bring out is where are the points of control inside that home network, and they're the ones that we've labeled with the red dots here. So I think we're considering some of the issues that were highlighted in the last discussion about, for example, what if somebody installs a Pi-hole or their own DNS server inside their home network? How does that change things? What if somebody has done some configuration on their operating system, then the application chooses to ignore that, or what does that imply? So those are kind of some of the questions that we try and at least highlight without necessarily giving black and white solutions, but pointing out that these are things that people actually do, and these are things that need to be considered. Next slide, please. So the sort of main recommendations are the ones on the slide here. And I think the first one, again, obvious to this group, which is that companies need to develop both organizational and technical responses to the changes in DNS security. And I think there is a whole set of communication problems about how do you explain to people who are impacted what the impacts are, and these include security experts and users and all kinds of different people, lawyers in some cases in organizations. So this whole, I think, question about communication is perhaps undervalued in a lot of the discussions so far. But then there are also the technical responses that I think we're much more familiar with inside this group. The second point, again, probably fairly obvious to most people here, but probably not to everybody in the industry, which is that in the absence of industry norms about how to deploy and operationalize encrypted DNS in servers and clients, people are developing very piecemeal solutions that differ in each implementation. And that is generating a lot of complexity and a lot of variation in the norms. And I think that brings us to the third recommendation, which is that we need to have more cooperation in the industry to generate common approaches to dot and do deployment and to reduce this complexity. So then we looked at client behaviors, and coming at this from the point of view of this idea of DNS as a network service, we're really strongly drawn to the idea of the same provider upgrade strategy, such as that being done in Chrome and proposed for Windows. We think that's the approach that's most compatible with existing DNS services in carriers and enterprises. And we really recommend that approach where possible as the basis for further development. And then I think the last point may be a little bit more contentious, or at least has longer term implications, which is that as a result of these changes in DNS security, it may be that existing network DNS implementations are no longer viable solutions for specific requirements, potentially including regulatory requirements. And if that is the case, then we don't have much option other than to start considering alternatives to DNS as to how these requirements may be met in future. And I guess that could mean, it could mean installing software on endpoints. I think that would be highly undesirable, at least in the Western world, but it's certainly a possibility. I think it also potentially includes things like requirements that are sort of typically manifested on ISPs DNS today could be generalized to include cloud-based DNSs such as Quad 8 and so on. I mean, that's more in the regulatory type domain, but I think that's something that will be considered if it becomes clear that ISPs DNS are no longer effective control points to meet government objectives for this kind of thing. So I think those are the key recommendations that I would take away, but there's quite a lot of more detailed points covering sort of item by item for different constituencies such as carriers and users and so on. Last slide, please. So if you want to have a look at this document, how do you get it? Basically, there's a press release there which includes the report, but if you want to access the report directly, then you can use the link there. And this is available for free.
I'll put
so that's
notes as
kind
well.
of a quick summary.
Sorry, and I'll put both of those links in the notes as well, and you'll see that the link to the paper is also in the chat and in the meeting invite. So one way or another, you should everyone have that.
Nobody has an excuse.
Quite. Okay, let me stop sharing then. Say thank you, Iain, for that quick run through. Does that prompt any immediate questions from anyone?
I've got one, if nobody else has.
Yeah, go on then. Far away, Jim.
Thanks. It was also something that came up in Neil's presentation as well, this notion of the same provider model. And I'm wondering how much this correlates with the data that Jeff Houston's been gathering on resolver traffic and resolver analysis from his global AdSense network. And I vaguely remember Jeff saying on quite a few occasions that there are lots of small ISPs that are now essentially throwing DNS resolution over the wall to Google, and they don't do it themselves anymore. So we may find a situation, with the exception of some of the really big players, like for example a BT or a Deutsche Telekom or a Vodafone or Comcast, a lot of these other guys are not really going to be involved in running DNS resolution services at all. And what do we then have to do or have to say about those particular scenarios? So I think we have to be careful when we're talking about the statistics about those numbers, and somehow make sure that whatever measurements and information we have about that is at least correlated with Jeff's data, or we've got a valid answer if someone says, well, Jeff Houston says X and you're saying not X, who's right?
Yeah, I mean, I think that's a fair comment. I think the ATIS report is obviously strongly coloured by the membership of ATIS, which tends to be fairly large North American, large and medium size, I would say, North American carriers and some of the sort of higher tier enterprise type organisations or enterprise network vendors. So yes, I think it's probably primarily reflecting the point of view of these kind of fairly large, sophisticated organisations that almost certainly are managing their own DNSs. But I agree that the world is a big place, and there are certainly a very large number of much smaller entities that need to be factored into this as well.
I think it's also true in some geographies, it's less common for the ISP to do their own DNS. So I think it's more common in North America and Europe, less common in some other parts of the world, from memory. Okay, thanks, Jim. Anyone else have any questions or comments you want to make based on what you've seen from the presentation and or paper? Reminder to come off mute if you are saying something. Moment or not. Okay, I'll take that as a no. So thank you, Iain. That's much appreciated running through that, and I hope that will be of interest to people. And as I say, the link to both the press release and paper.
Sorry, Andrew. I have a. Can I jump in? Just yeah. Sorry. Just have a question. What does Iain see as the natural next step to this work?
Yeah, that's a good question. So I think that what we've discussed in the group is that we obviously have the ADD activity happening in IETF now, and we have a certain amount of consolidation and behind what Google and Microsoft have proposed. So I think at the minute our kind of idea is that we're going to watch those stories develop and see if they are making good progress, and hope that they address the sort of short-term issues. But I think that we may decide that if we don't see good enough progress, then we may want to do more technical work in ATIS. But for now, we're going to try and coordinate and help the members to make progress in EDI, IETF on these topics.
Thank you.
Great. Thank you, and thanks, Iain. So as I say, you'll have the links to the paper if you want to read that offline. Thanks, Iain, for running through that. Right, we're in the sort of last few minutes of the call, so we're on any other business. I've got one thing to highlight, but before I do that, does anyone have any other business you would like to raise on the call?
Yeah, Andrew. Hey, Glenn here. Sorry, I had a to-do from last week to kick off some EDI discussions. Sorry, I took Friday off and didn't get to it, but I will be doing it this week. So check your inboxes this week for a link to sort of an EDI session. I'm exploring using Slido to manage sort of discussions around use cases. If anybody has any experience using Slido for running meetings like that, please drop me an email. I'd be interested in hearing your feelings, or if there's a better tool.
Okay, so if anyone has used Slido in that way, some expertise to share will be much appreciated. Yeah, okay, and I'll put that in the notes as well as a reminder. Okay, thanks, Glenn.
And
yeah, Zaid?
Yeah, sorry, Andrew. One other question, and one of the questions that were given to Iain mentioned Jeff's data. Who's Jeff and which data?
That's Jeff Huston and Apnic. He shared some of his data on this call a few weeks back. I haven't got it to hand. I'll happily drop you a line separately with because we recorded the presentation, so it'd be well worth watching that. He's based somewhere in Asia Pac. I can't remember which country, possibly Australia or somewhere like that. So it was a relatively early morning call that we did. So not this time of day. So anyone in the US would certainly have missed it unless you had a sleepless night that night.
Just to put a little bit more detail, Jeff's the chief scientist at APNIC, the regional internet registry for the Asia Pacific region. And he's been around the IETF for a long, long time as a former member of the IEB. And him and a couple of his colleagues have built an infrastructure for doing all sorts of measurements, particularly around the DNS, that's based around Google's AdSense network. And this is really, really clever. So the basic idea is he puts up boring adverts, which are then tied to unique domain names, which are one-offs. And provided people don't click on the adverts, he gets information back from Google about which clients have actually referenced that web page. And of course, he then doesn't have to pay Google because the clicks haven't been activated and there's not being pay-per-click revenue. And he's gathering all sorts of data about things like DNS validation techniques, where traffic is coming from, who's looking up what ISPs are doing, so you can actually see the internal addresses that are being used inside an enterprise or in an operator network for the end clients when they're making DNS queries, because they've got that end client linked to the web page that's been referenced. fascinating stuff, and Jeff's got tons and tons of data available.
Yeah, it's also rather scary if you didn't realize how much data advertisers can gather. Even as Jim said, if you don't actually click on the adverts, it's well worth watching the presentation for that alone, if nothing else.
Thank you.
Okay. Right, anyone else with any other business you wish to raise? In which case, I'll just mention one other thing, which is we've talked briefly on this call before about Eurodig, which is due to run in June. The registration for Eurodig opened up on Friday. So if people wish to register, you can now do so. And again, I'll include a link to that and some other events with the notes from the meeting, so you can do that readily. It's free to attend, but you do need to register to attend. It will be run on Zoom this time, so it'll be an entirely virtual event for kind of obvious reasons, as it's based in Europe. And there's quite a few quite interesting sessions, including one or two that I and some others on this call are involved with. So do have a look at the agenda and hopefully sign up, and so you can take part in the sessions. Okay, and with that note, we're a few minutes early, but thanks everyone for coming on. I hope you found that useful. And as always, if there's stuff you want to cover on the call, just drop me a line, and we can certainly accommodate you on one of the future calls. But other than that, have a great week. Thanks everyone, and speak to you later.
Thanks, Andrew. Cheers.
Thank you.